right, your job is to, in your notes, label it. Label your notes tangents to circles. Tangents, pronounced exactly the same way as tangent, like sine, cosine, and tangent, but it means something completely different. So the word tangent shows up in two different ways in this unit. One way it shows up is when we're talking about SOHCAHTOA, the three trig ratios, and it also shows up in this context right here. So before we go on, what I need to do is tell you what is a tangent. What is a tangent line? A tangent line. A tangent line is a line that intersects a circle at exactly one point. A line that intersects a circle at exactly 1 point. What I need you guys to do is draw yourself a circle. The best you can. They're hard to draw. A perfect circle. All right, so you have a circle there, and your job is to draw for me a tangent line to that circle. How are you going to draw a line tangent to that circle if it can only intersect the circle in exactly 1 point? Keeping in mind, let me say one more piece of information, a line. That means it goes infinitely far in both directions. It has to go forever far in both directions. How can a line be tangent to a circle? In other words, intersect it in exactly 1 point if it goes infinitely far in both directions?
It's impossible.
It is possible.
You can make it
It's the ring.
Yes. You can make it up on top of or on the side of or whatever the circle. This right here, and they're tricky to draw. That is a tangent line. Touches a circle in 1 point. At 1 point, correct?
Sure.
Yeah. All right. Let's draw a point in the middle of the circle too, and I'm going to label it P. P for point, I guess. Circles are identified by their center point. So in this case, we would call this circle P. This right here, what do we call this line?
Tangent line.
It is a tangent line. Very good. And it intersects that circle in one spot. And it's hard to tell that it looks like it's more than 1 point, but it's hard to draw them so that they very, very specifically cross that circle in exactly 1 point. But what I would like you to do now is draw yourself a radius in the circle. And the radius, hopefully you guys know, goes from the center of the circle. I want you to draw your radius to the tangent line. I'm going to label it R, Y-R, lowercase r, for what? For the radius. Yeah, okay. So every tangent line to a circle creates a 90-degree angle with a radius of the circle. So this circle has an infinite number of radiuses, by the way. Radiuses is not a word. What do you call more than one radius? A radii. R-A-D-I-I. So this radius creates this is the radius that creates a 90-degree angle with the circle. So go ahead and draw yourself a 90-degree angle right there at the corner. So I'm going to make a note here, and I'd like you to do the same, that tangent lines create a 90-degree angle with a radius. Now, there is a very specific radius that it creates a 90-degree angle with. But but usually in these kinds of situations, you will be given the radius, or I will ask you, I will have the radius drawn in, and I will label it for you, or I may say, figure out how long the radius is. But you don't need to know exactly where to draw it. You just need to be able to come up with a picture that looks like this. Just make it look like a 90-degree angle to the best of your ability. All right. Can I flip pages here? All right. Draw yourself another circle. And what I would like you guys to do is draw a line that looks like it's tangent to the circle. So draw a tangent line. Draw a tangent line to the circle. And I want you to draw in the radius that creates a 90-degree angle with that tangent line. But don't label it a right angle. Make it look like it's a right angle. And then I would like you to finish off your circle by connecting the center of the circle, which I'll call O this time, to this point outside the circle. And I want to know, is the line that appears to be tangent actually tangent? Is the line that appears to be tangent, that you drew to be tangent, is it actually tangent? No. And I'm going to tell you this, that the radius is 5, so we'll go ahead and label that 5. And I'm also going to tell you that this right here is 12, and I'm going to tell you that this right here is 13. So what is 13? What is 13 called? It is the hypotenuse. But it is only the hypotenuse if this is in fact a what? A right triangle. And if it is a right triangle, that would mean that right here in this corner there would be a right angle, which means then that this line that I have labeled with a 12 is tangent to the circle. So if I give you these 3 pieces of information, 5, 12, and 13, how would you go about figuring out whether or not that line segment that's labeled 12 is really a tangent line? What would you have to do? Go ahead, Moses, is this?
C squared minus B squared.
Okay. So in other words, you are thinking Pythagorean theorem right now, right? Yes, absolutely yes. That is what you should be thinking, the Pythagorean theorem. Now, he said something about something squared minus something squared. But this is the deal. In this problem, I give you all 3 sides. I give you all 3 sides of the triangle. Just check to see if the Pythagorean theorem worked. What are you going to do?
Square all of them?
Square all of them. Very good. We're going to check to see if a squared plus b squared is actually equal to side c squared. Okay, so what are we going to call side A?
5.
Or,
12.
doesn't matter which one. I'm going to do 5 first. 5 squared plus 12 squared. 5 squared plus 12 squared. And we have to see if the answer that we get when we do 5 squared plus 12 squared, does that answer get us the same answer as when we take the hypotenuse squared? So 13 squared. So, go ahead and do this. What is 5 squared plus 12 squared?
169.
It is 169, and if you can't do the math in your head, it's a calculator problem. 169. What is 13 squared?
169.
169. Is it tangent?
Yeah.
Is the line tangent? You say yes. Yes.
A lot of work for a yes.
The line is tangent. And the reason it is because this is a true statement. Let's say that you ended up with 168.4 over here. Well, is 169 the same thing as 168.4? No. No. If it doesn't work out exactly, then it doesn't work. It would be a no. All right, let's try another one. Draw yourself a circle. Draw another circle. Draw a line which appears to be tangent to the circle. Go ahead and draw in your radius. finish off your triangle. And what we're trying to do is figure out whether or not that line segment on the outside of the circle is a tangent. So is it tangent? So I'm going to tell you that this thing right here is, I gotta back up a page here. Let's say this segment right here, I'm gonna say is 20, and I'm gonna say also that the radius is 4, and I am going to tell you that this from here to this point out here is is 18. It's 18. And your job is to figure out whether or not that segment is tangent. So what are you guys thinking we probably are going to have to use again? The Pythagorean theorem. We're going to have to do that, but we're missing a piece. How was your hand up, or were you stretching?
Why was that? I have a question.
Yeah.
Would it be 4? Like, inside of that?
Yeah. Why? How do you know that the distance from here to here is 4?
That's the rate.
Because it's the radius. And anywhere that I draw a radius in that circle, it will always be exactly the same as any other radius in that circle. So if the distance from here to here is 4, the distance from here to here is also 4. So what is the total length of that segment then? It's 22. So I'm going to cross off the 4 and cross off the 18, and I'm just going to label it as a big old 22. Where is the right angle, you guys? Is the right angle here, or is it here?
It's inside.
On the other
Okay,
side.
so that's where we need to talk. If it is tangent, the tangent line, this would be the tangent line, because this is the line that's drawn like on the outside of the circle. It has to make a 90-degree angle with the radius. So this point right here, if this is in fact a right triangle, this is where the right angle would be. But do you see how that other angle certainly looks like it could be a right angle? Yeah. That's because I'm drawing all this freehand and I'm not doing a fantastic job. Which means your pictures that you will have to draw someday, soon, will not be perfect either. So you need to make sure that you are using the things that I've taught you to decide whether or where the right angle is, okay? The right angle is always here. It's always kind of toward the outside of the triangle that you've drawn, okay? Let's check to see if this works. Is 4 squared plus 20 squared, is it equal to what number squared? 22 squared. Is 4 squared plus 20 squared equal to 22 squared? So, do the math. This is 16, this is 400. So I think you get 416 over here. Alright, what is 22 squared?
484.
What is it?
484.
484, okay, thank you. 484. Is this a true statement?
No.
It is not a true statement. They are not equal to each other. So no, it is not tangent. Are you okay with what I just talked about?
Yes.
You have to do this yourself soon? Yes.
Which one will be the hypotenuse?
Which one would be the hypotenuse? The hypotenuse is going to be this one right up here. This 22.
Do you want
Here is your right angle. Here's your right angle. So it has to be across from your right angle. So this side right here is your hypotenuse. Okay? And this picture is very deceiving, wouldn't you agree? And one of the reasons I did this with you specifically is because I oftentimes see students draw the right angle in the center of the circle. That's not where it goes. It goes outside. It goes out here in this corner right here. Okay? All right. Someone else had their hand up. I felt like, yes.
Do we have to write? Can we just put no, not?
Well, I'm going to expect to see this right here.
Uh-huh.
And then you can write no.
I was just wondering if we could just write no, not the other.
Oh, you mean no, it is not tangent? You don't have to write that part. If you just write no, that's fine.
Okay.
Alright, draw yourself another circle.
It's strong right here.
Draw yourself another circle. Draw a tangent line. But this time when you draw, and actually these lines that I've been drawing lately have been not necessarily tangent lines. They've been line segments. Why are these segments and not lines? Yeah, I'm not excited. I'm not drawing arrows at the end and saying they go on forever. I'm saying it starts here and it ends here. So they're line segments, not lines. Draw yourself a point right out here. Label it P. And that point right there is what we call an exterior point. Why is it called an exterior point?
Because it's outside of the circle?
Well, because it's out, because it is exterior. It is, Anthony? It is outside of the circle. It's outside of the circle, so it's an exterior point. Now, draw yourself a point in the middle. I'm going to call it O. Connect your radius to your tangent line. Now, I'm telling you that this line is tangent. So, if it is tangent, what do you know about this corner right here?
It's a 90-degree angle.
It is a 90-degree angle, and you can only write a 90-degree angle in there if you already know that it's tangent. I'm telling you it's tangent, so you can assume that. So go ahead and draw your right angle in there. And then I want you to connect point O to exterior point P. Connect those two. What have we created here?
A triangle.
You created a right triangle. Now what I would like you to do is make your drawing even a little bit more complex. And I want you to draw for me another radius. So from the center of the circle to the outside. But I want you guys to draw your radius in such a spot so that when I connect the end of that radius to exterior point P, it will also be tangent to the circle. So in other words, I'm going to draw another tangent line here, and I'm going to draw in another radius. Now, if this thing right here is in fact tangent, what do I have going on right here?
Right triangle.
Another right angle. So I have two triangles, and it just so happens that these two triangles are identical. Do you want your test? Yeah. They are identical. Two right angles, two tangent lines, and the reason I'm talking about this is because I need to tell you guys that this line segment right here, this tangent line segment, is exactly the same length as this tangent segment. And that is only true when those tangent lines are drawn from what?
One point.
The same exterior point. If they are drawn from the same exterior point, then those two tangent line segments are equal in length. So we need to write this. Tangent lines, I'll try to keep this as brief as possible. Tangent lines drawn from the same exterior point are equal in length. So let's say that I tell you that this tangent segment up here is 19 centimeters long. How long is this tangent segment?
19.
It is also 19 centimeters long. All right, I have one more example to give you, and then I'm going to stop talking. Can I flip pages? You guys done with this? Locke, are you done? You got this already? Draw yourself a circle. And what I would like you to do is I want you to draw a triangle around your circle. And when I say draw a triangle, I want your circle to be completely lodged right inside of it has to be inscribed the triangle. So, these are trickier to draw.
Oh,
A cone.
I drew it wrong.
Oh, shit.
That's how you wanted me to draw it.
Not a great picture, but you get my point here.
It's the best.
And what I would like you to write next to this picture is that all segments that appear to be tangent are tangent. So in other words, any segment in this picture that looks like it's tangent, it is tangent. So in other words, I'm not going to go through and write in the little right angles for you. I want you guys to assume that if it looks like it's tangent, it's just tangent. So do you see what I'm saying? All three of the segments that make up the triangle, every single one of them is tangent. Are you okay with that?
Yes.
They're all tangent. So do you see this exterior point out here? What does it mean about the segment from here, the tangent point, to that exterior point, and this tangent point to that exterior point? They're exactly the same. So I'm going to label this as being exactly 8. I also want you to know that this length right here is 2, and I want you to know that the length from here all the way to here is let's say it's 6. I want you guys to find the perimeter of the triangle. So the perimeter of the triangle equals what? Our job is to figure out what that is. So let's start from the beginning here. We know that the distance from here to here is 8. So what did we say about this distance right here? It's also 8. We know that this little distance right here is 2. So what does it mean about this distance? It is also 2. Well, if the total distance on that side, the left side of that triangle, is 6, what does it mean about the distance from here to here?
6.
No, just from here to here is going to be 4, because together the 4 and the 2 need to make up the 6. And then if the distance from this point to down here is 4, what is the distance from here to this point? It is also 4. So what is the perimeter of the entire triangle, the perimeter of the triangle? So let's add, perimeter means the distance all the way around. So we have a couple of 8s that we need to add together. We have a couple of 2s that we need to add together. And we have a couple of 4s that we need to add together. So we have an 8 times 2, plus we have a 4 times 2, plus we have, what am I forgetting? 2 times 2. 8 times 2 is 16. 4 times 2 is 8. 2 times 2 is 4. So we are adding together 16 plus 8, which is 24, plus 4 more. That gets me a total perimeter of what, you guys?
28.
28. And if it's inches, it would be 28 inches. Are you okay with this?
Yeah.